So we're going to get started with some practice for today. So even though if you're in here, make sure that you're joining the Zoom as well. And I'm going to open up the camera here so we can take a look at the notes for today. All right. So if you remember from yesterday, what we were doing was using factoring as a method of solving our quadratic equations, okay? And we walked through the steps for it, right? And we kind of talked about it as we were going over the homework from last night as well. We first want to make sure that our equation is set equal to 0 and that the highest exponent has a positive coefficient, okay? Once we get to that step, we have everything to one side. We have everything set equal to 0. We want to make sure that we factor, and we talked about all our different factoring methods. From there, we're going to set each factor that we have equal to 0, okay? Now, we saw an example very similar to number 9 yesterday, but I'm going to go through this again just so we're aware of that final step that we can add on top of all of our different factoring tools we've discussed this week. All right? So in number 9, we have 5 times x minus 4 times 3x plus 1 times x minus 2 equals 0. Each of those terms can't be factored any further, okay? So what we want to do is set each of them equal to 0. Now, this is the first time, or maybe we saw it last night on the homework as well, where we have a GCF that's a constant term. And when that's the case, when I just pull out a number as my GCF, I don't want to set that equal to 0. Okay, and we're going to see an example later on too where we have a similar case. I'm not going to set 5 equal to 0. I'm just going to let that constant term go. And I just want to deal with each of these individual factors here. So I'll set up some equations where I'll have x minus 4 equals 0, 3x plus 1 equals 0, and x minus 2 equals 0. Right, so this is that last step that we discussed yesterday. After we factor and we have these equations now instead of expressions, we want to set each of them equal to 0 to solve. So I'll add 4 to both sides. All of these equations will be 1 and sometimes 2-step equations. I get x minus 4 as a solution. In this example here, or this factor here, I have a 2-step equation, so I have 3x equals negative 1 after subtracting on both sides. I get x equals negative 1/3. And in this last one, I'm going to add 2 to both sides. I get x equals 2. So hopefully we remember the steps here for solving, and then that very last step. Yeah, question. So the 5, that's what I was discussing earlier, where if it's a constant term, you just let it go. Because if you set 5 equal to 0, that doesn't make sense, right? If you have 5 of something, it's not the same as having none of something. So you just leave the constant term. The only time that you would have to worry about the GCF is if it has a variable attached, like an x or anything like that. Good question. I have x equals 4, x equals negative 1/3, and x equals 2. If we were to plug each of those values back in, right, these are my solutions, it's going to make my equation 0 equals 0 on both sides. And also, if you were to graph this equation, you would see that the graph crosses the x-axis at x equals 4, x equals negative 1/3, and x equals positive 2. Okay? So just be aware of the theory behind what it means to be a solution or a 0 or an x-intercept. Okay? Any questions about number 9? Okay. Let's make this a little bit more collaborative today. So hopefully we're all able to participate. We've seen this a lot now. We've seen all the different factoring methods. The only added step is to set them equal to 0 and solve after to find my solutions. But we should be familiar with what we need to do here. Number 10. I have 2x squared plus 6x minus 20 equals 0. All right. First thing I want to do is make sure it's set equal to 0, which I have. The next thing I want to do is check all my different factoring methods. Remember that we have that sequence, GCF, special patterns, factor normally, or slide and divide. Looking at number 10, do I have a GCF? Is there anything that I can take out? Take a 2 out. Good. And when I take out a 2, what's left over inside my parentheses? So I have x squared plus 3x minus 10, right? Good. So I take out that GCF. I take a 2 out of each term. And that's all I can take out, right? Because they don't each share a variable. So I have 2 times in parentheses x squared plus 3x minus 10, 0. Okay. Now I'm going to keep that 2 on the outside, and I need to think about everything inside my parentheses. Well, I'm not going to have a GCF again, because otherwise I would have already taken it out. I want to go to my next factoring methods. I don't have a special pattern. And the number in front of my x squared is just 1. So I need to factor this normally. Okay. I know I'm going to have an x and an x. And I'm going to think about factors of 10 that will multiply to give me negative 10 and add to give me a positive 3. Now, one thing that we talked about yesterday that we want to make sure we keep in mind is that when we're multiplying to get a negative number, that means that I'm going to have a positive number here and a negative number here, right? Now, it doesn't matter the order necessarily, but you know that one of your factors there is going to be positive, one has to be negative. So which 2 numbers are going to multiply to give me a negative 10 and add to give me a positive 3? Good. Positive 5 and negative 2. If I were to FOIL that back, I'd get x squared minus 2x plus 5x. Well, that's how I get the 3x. And then 5 times negative 2 gives me the negative 10. What do I do from this step now? So I have 2 times x plus 5 times x minus 2. What would be my next step? Good. Set each factor equal to 0. And I only want to deal with everything that's inside my parentheses right now because the coefficient, or excuse me, the greatest common factor that I took out doesn't have a variable. So I'm going to leave the 2 alone. And I'm just going to set x plus 5 equals 0 and x minus 2 equal to 0. Now I have my one-step equations. Subtract 5 from both sides to get x equals negative 5. Add 2 to both sides to get x equals 2. And each of these here are my solutions to that equation. Any questions about number 10? Okay. Number 11. What do I notice that's different about number 11 in comparison, to number 9 and number 10? Okay. Right, so I have a y squared that's by itself. Now we don't want to think about it as like where the 0 should be, because one thing that we talked about yesterday in class was that we want that highest exponent to have a positive term, positive coefficient, and it does right now. So I don't want to necessarily move the y squared. I want to make sure that stays positive. I want to move everything else. So you're right, we want to make it equal to 0. And to do that, what am I going to have to do over there on the right-hand side? Right, subtract the 10y and add the 21. I'm going to show two steps at once here. So I have y squared minus 10y plus 21 equals 0. Now I have everything on one side. It's equal to 0. I want to think about my different factoring methods. Do I have a GCF? No. Do I have a special pattern? No, right? Y squared minus 10y plus 21. 21 can't be broken down in the same number twice, being multiplied together. I have a 1 in front of my y squared. I'm going to factor normally. So I know I'm going to have y times y. And I'm multiplying to get positive 21, but adding to get negative 10. So I need to think about two numbers that will multiply to give me a positive 21, but add to give me a negative 10. Yeah. Good. -7 and -3. Awesome. Whenever we have that negative sign in the middle followed by a positive in the last term, it's always going to be a negative times a negative to get me that positive, right? Remember, there's two ways that you can get a positive number by multiplying: positive times positive and negative times negative. All right, so we need that same sign in the middle there whenever our third term is positive, and it really only depends on what the middle sign is as well. And now I have y minus 7 and y minus 3. I'll set each of those equal to 0 and solve. I get y is equal to 7 when I add 7 to both sides. Add 3 to both sides. I get y is equal to 3. Any questions about number 11? Okay. Number 12. I have negative 3x plus 2 equals negative x squared. What's the first thing that I need to do here? Maybe somebody from home help me out with this. What's the first thing I need to do for number 12?
Add x squared to both sides.
Good. Add x squared to both sides. The reason I want to do that is because I want to set it equal to 0. But now here's a case where I want to move the x squared term because I need to make that positive as well. So I have x squared minus 3x plus 2 equals 0. Okay, now I go through my factoring methods. Do I have a greatest common factor?
No.
No, right? They're all actually prime numbers. I have the 1 in front, the 3 in front, the 2 in front. So now I got to think about, do I have a special pattern? Well, no, I don't have a special pattern either because 2 is prime. It's just 2 in itself, or 2 in 1, excuse me. I'm going to factor normally here because I have a 1 in front of the x squared. So I'll do x and x. Again, notice that I have a negative number in my middle term and a positive number in my outside term. So I'm multiplying two numbers to get a positive, but I have to add to get a negative. Well, one thing that's nice about that third term as well is that it is prime. So what are the only two factors of 2? Just 2 and 1. The only thing here that we need to be careful about is the sign of each of those. Multiplying to get a positive, but adding to get a negative number. What are the two signs? Negative. Yeah, so we're still in the notes from yesterday. We're just doing the examples 9, 10, 11, and 12. So like the try it section. I got x minus 2, x minus 1. What do I have to do with each of those factors? Right, so each of these equal to 0. And what are my two solutions then to these equations? X equals 2 and x equals 1. Okay. Any questions about that example there? Anything at all on this page? 9, 10, 11, or 12? Okay. We'll flip over to the next page. We'll do a couple from this as well. Starting with 13. Number 13, I have x cubed plus 7x squared plus 12x equals 0. In all the examples that we've seen so far, we either had it factored out for us or we factored with an x squared term, right? That was the highest exponent. In this one, we have an x cubed. In any question where you have an x cubed, we don't know how to factor that right now. So what we need to think to do is find a way to make that an x squared equation. A lot of times we're going to have a GCF, okay? Notice that each of those terms there shares a common factor. What is that common factor? X. So I'm going to take out an x here in 13. It's off to the side. And when I take out an x, what's left over on the inside of my parentheses? X squared plus 7x plus 12. All this still equal to 0. I'll leave my GCF on the outside for now. Well, first off, does anybody have any questions about that first step? Because we haven't seen too many GCF questions yet, but that's an example there where we take out an x. Now I need to look inside my parentheses. I'll leave the x on the outside. I don't have a GCF again, right? Because if I already had a GCF, I would have taken it out. And I don't have a special pattern because 12 doesn't break down into the same thing being multiplied together twice. I need to think to factor normally here because I have a 1 in front of my x squared. Two factors that are going to multiply together to give me a positive 12 and add to give me a positive 7. Maybe somebody from home help me out with this one. If I'm multiplying to get a positive 12 and adding to get a positive, to get a positive 7, what are going to be my two factors?
3 and 4.
3 and 4. And they're both positive, right? Notice that each of my terms there are positive. So it's going to be a positive 3 and a positive 4. Now, this is probably one of the first times we've seen where my GCF also has an x attached. Now, in the first couple examples, we saw that it was just a constant term that I took out. When I have a variable as one of my GCFs, I still have to make sure I set that equal to 0 as well, because that's one of my solutions. So I'm going to take each of these terms now that I factored and set them equal to 0. Well, that first term is just x. I have x equals 0. I don't have to do any work for that. That's just one of my solutions. Any questions about that? So there's no work that you really need to show. My other two of x plus 3 equals 0 and x plus 4 equals 0. So then what should be the two solutions, the two other solutions to this equation? Right. -3. So I subtract 3 from both sides to get x equals -3, and -4. Subtract 4 from both sides, I get x equals -4. Okay. Any questions about example 13? Okay. Keep trucking along here with 14. I have x cubed equals 25x. It's the first thing I need to do. Subtract 25x from both sides. Again, I don't want to move the x cubed at all because I want to make sure that that highest exponent is positive. So I'll subtract the 25x from both sides. And I have x cubed minus 25x equals 0 now. Well, just like in the last example, I have an x cubed here, minus 25x. I want to think to maybe take out a GCF. Do I have a GCF, something that I can take out of each of those terms? What's that? X. Exactly. They both share an x, so I can take that out. And I'm left with x squared minus 25 inside my parentheses, all set equal to 0. Again, I have the x on the outside. I'll leave that be. I want to factor what's inside my parentheses. How would I factor the x squared minus 25? What does that become? X minus 5, x plus 5. Good. This is what's called our difference of squares. Remember, I said if we have two terms, we should always think to do one of two things. Take the GCF, which we actually started out by doing here. And then I'm left with two terms still. A lot of times, if it's like x squared minus 25, x squared minus 9, x squared minus 16, I have positive -3, -4, positive -5. That's what I can factor to help me find all of my solutions. So I have x plus 5 and x minus 5. What do I do from this step here? Set each factor equal to 0, including that x on the outside, right? So again, I'll have x equals 0, x plus 5 equals 0, and x minus 5 equals 0. So what would be my other two solutions? I know x equals 0 is one of them, and the other two would be what? X equals -5, and x is equal to positive 5. Okay. Any questions about 14? Now, another thing that you could have done with 14, just as kind of a side note here. Once you get to this step, the x times the x squared minus 25, okay? I'm going to do the work for it kind of up here in this margin. X squared minus 25, you could actually set that equal to 0. So a lot of times we have just 3 terms, right? On the inside, we need to factor it further. The x squared minus 25, I can set equal to 0 along with the x from that step. Now, I would like to see you factor it, but this is just another way of solving, just so we're aware of some different methods that you might see throughout the course, especially when we start talking about square roots. I have x equals 0, and I have x minus 25. I'll set that equal to 0. Well, this is already one solution here. How would I get the x by itself in that second equation? Very similar to what I do in any other equation. Okay. Exactly. So I add 25 to both sides. I'm left with x squared equals 25. Now, something that you might have seen in a previous class, or maybe, throughout just doing math in general, I'm squaring something. Usually we just have an x by itself. Well, I still have an x squared. When I'm squaring something, to get rid of that, I can take the square root of both sides. The square root's the opposite of a square. So instead of multiplying a number twice, we're trying to find, well, what number, if I take the square root, am I left with? The one thing that you need to be careful with, though, when you're taking the square root of a number, you're left with x is equal to both positive and negative, whatever the square root of that number is. So in this case, square root of 25 is 5. I take the square root, I'm left with x equals positive negative 5. Well, notice that when we did the difference of squares, we were left with x equals negative 5 and x equals positive 5. So either way that you could have done this, whether you stopped here and set them equal to 0 or continued to factor and set them equal to 0, you would have gotten the same answer. Now, on a test or quiz or on your homework, I'd like to see you factor, but that's just another method that we'll eventually get to as we move forward. It also saves you maybe a little bit of time. Okay. Any questions about 14? Last one we're going to do is 15. I have x squared plus 10x plus 25 equals 0. Somebody walk me through this problem. How would you accomplish this? What would you need to do? Okay, so there's not a greatest common factor. So you want to just do it normally, okay? Because I know that I have a 1 in front of the x squared, right? That's what allows me to just factor normally. So now what do I have to do? And positive 5, right? So I need to, exactly as you said, I need to find 2 numbers that will multiply to give me 25, add to give me 10. In this case, it's actually positive 5 and positive 5. Now, that's perfectly fine. Another way that you could have done it, remember that between GCF and factoring normally, I have what's called a special pattern. So if I were to look at this, and either way, if you factor it normally, you'll get the same answer. But if you were able to recognize to do it this way, you would have been fine as well. Notice that x squared breaks down to x and x, 25, 5, and 5. Remember that if I want to check my middle term, it needs to be 2 times the product of those individual terms there. So 2 times 5x, that gives me 10x. And I can just immediately write my answer without really thinking about product or adding up to get this middle term. I can write my answer as x plus 5 quantity squared, which is the same thing I get by factoring normally. What do I have to do with each of those terms there? Set it equal to 0. Now they're the same thing. You're going to get the same answer. So don't do double the work, right? Just set one of them equal to 0. I have x plus 5 equals 0. So x equals -5. And what's different about our answer to this one comparative to maybe some of the other ones that we've seen on this page or on the previous examples? There's only one answer. The reason for that, if you remember from last week, and we're going to review it a little bit next week too, remember that if I have one solution to an equation, what the graph looks like of that, and I'm going to kind of sketch this out. I have my XY plane. It's that parabola, it's that U shape still, but it's one solution. All it's doing is touching the x-axis at that point. It's not crossing like it might have in another solution. So at -1, 2, 3, 4, 5, my parabola is opening up like this and just touching at that point, but never crossing. And we're going to talk about that a little bit more next week again to review that concept, but that's what it looks like when you have one solution. Okay. Any questions about that last example or anything that we have done today? 16, sure. Just curious. So you have x cubed minus 5x squared. Your GCF that you can take out of 16 is an x squared. So you want to take out the highest, the greatest factor that you can. When you're left with that inside the parentheses, you have x minus 5. And then from there, you'd set each term equal to 0. Well, just like in 14, to undo a square, you take the square root. So you have x squared equals 0, take the square root, and you just have x equals 0. And then x minus 5 equals 0. Add 5 to both sides, you have x equals 5. Yeah. So you see the x cubed, a lot of times you want to find a GCF. And you want to take the highest one out. So if you just took an x, you'd still be left with an. Right. So you want to take out 2, whatever the most that you can take out. Good question, though. Any other questions about any of the examples we've done today? Okay. Give me a second here. I'm going to stop sharing my screen.